start any program, we can, for example, I am right now working on this dam. I need to load this program. Once it is loaded, it will appear in the bottom menu. You can edit the program. If we click edit program, it will show up the program steps. So in these steps, this first section is more of a global parameters and configuration of, for example, CTC height is the chip to chip height. That means when from one chip to another chip in the same PCB, it will jump to this much height, and PCB height is the gap between the PCB and the reference point position. And similarly, there are other, for example, this dispension per millimeter. So that means 6 millimeter cube per millimeter. So it's a line weight. And similarly, there are dispensing delay. So there will be a delay in the initial point to start dispensing. So it's 0.22 seconds delay. Dispense distance, so same, but in terms of distance. And dispense calm, it's at the end, like when it is travel the pattern, internet pattern, and it will delay 2 seconds before it moves the needle up. And red run distance and red run velocity are the it's for example, in the when you do a pattern at the end, you will want to run it slowly. So that's what the red run means. So here it is disabled, that's why red run distance is 0. And if it is enabled, what would be the velocity? Would be red run velocity 1. And global velocity and global VD distance and VC in the set direction. So those are 30 millimeter per second and 10 millimeter per second. And multi is if it is for multiple PCBs, like in a setup. And global VD and VSET, those are different parameters. I think it is this specific for maybe in when you are programming and in the production. So this is the factor in which the actual set velocity will be reduced. So it is set to 10%, 50%, like that. Here in terms of program begin end, so this is they name the pattern as chip, and that I will explain when in the programming menu. But the name here is for that specific chip is NECA F7, and XY, this denotes the initial position from the reference point. So the reference point could let's say here, if this is the reference point, let's say in the PCB, the corner of the PCB is the reference point. The starting point is somewhere 15 millimeter in positive X direction, and minus 15 millimeter in negative X direction would be the starting point of running this NECA F7 program. So this is the NECA F7 program. The group 1 denotes what is the valve type or the valve group. So it will be, you can configure right now the one connected to this one. This is the configured as group 1, and this on is like start the dispensing. That means it will put the pressure, and here it is intended to draw a rectangle with this direct with these corner points. So for example, let's say the start point is here and the corner point will be here, so it will, by just providing one point, we define the rectangle. So the it will be like 17 into 17 roughly millimeters rectangle or square in that case. Then once it is dispensed, let's say start from this the point, this is the corner point from the reference point, and then it will dispense like this and create a rectangle. And once that is completed, we just off the dispense. So this is the, so I can show for the fill one. So here the fill would be different. So the reference starting point from the reference point is somewhere as similar to earlier, but here it is, instead of rectangle it will be snail. So in the snail again you need to define the corner points similar to the rectangle, and then D is the gap between snail pattern. For example, if it is going like this, the gap between, they call it as pitch as well. And R is equal to, when it takes the corner, R is the radius of the corner it will take when it drawing the snail pattern. So that radius is 0.1. That is what mentioned here. And after completing, it will wait for 0.1 second in the middle. So it will start in the corner, top left corner, and it will draw a snail pattern with a pitch of 0.5 millimeter and the corner of 0.1 millimeter radius, and at the middle it will stop and wait for 0.1 second before it pull up the needle, and after that it will dispense off, similar to the rectangle pattern. So this pattern is what differs. So there are different shortcuts, you can find it in the manual as well. So Control Q means like leap from that program. There are different things. I will explain. We have seen program administration. Let's go to the production. So production is like when you want to run a already defined program, and the program is like you program a new program, like we already have named a program but haven't done anything. So let's so okay, so here it start of the once it is started, it will ask for a reference move unless it will not allow you to move anything. So it will just allow you to do the reference move. So it is in the program, it is already we have loaded this program, so that's why it shows up. We don't want to edit this program, so we will go back to what the program we have defined, that is ABC, right? It says here 5, 6, 7.
Yeah,
Okay.
ABC.
So ABC, this is what we defined. We load this program and press escape, go to programming. So here in the programming, it's an empty program. So in the program, first we need to define the general parameters. So the reference point position, like in the program I mentioned, like from the start point to start position of the actual program. So reference position, so it is, unless it provided just the actual position of the camera. So let's say if I wanted to move the thing, I can use I need to click one, maybe here, then I can wait, I can use this one to move the sample. We just need to show the position relative to the center position. So the center is current position of the system, and this is the direction we want to move. So by pressing the left button, it will move that direction. So we need to bring it to our side. So we just go. So let's move it to somewhere. So the camera will be the reference position, so it is easy to program. So we wanted to put the camera on the corner of the PCB. Let's see. So it is we can move the Z axis as well, so you can use even the plus minus. So it is plus means up, minus is down. You need to check this one to move a specific axis. So it is now clear. Now I can use this one to move to the intended position. So the further from this, higher the speed it will move. So if I want to move with the reduced speed, I will put it closer to the green point. So I think this is some holes. So let me focus it. So this is the PCB hole, like top left corner. So let's say I'm trying to position, put this in absolute different position as the corner of the PCB. Maybe little digest. So if we, let's say if we put okay, it is better to put it in the center, it is more easy. So roughly let's put this as the reference position, this small hole, or even we can put this hole as the reference position on the PCB. So let's say we put that as a reference position. It is more intuitive. Here we can name it as a reference position. We moved it to this position, so we can put it a reference position. So this is the reference position from the absolute one. So the position right now here is, it is reference to the stage absolute position. Similarly, we can put heights. It will ask to define the chip to chip height. So let's say in chip to chip height, we can move the stage up and down using this specify the axis. And let's say if it is
can I move more?
Yeah, plus it will move upward and minus downward. So this point